For an image generator to be able to respond to so many different prompts, it needs a massive, diverse training data set, like hundreds of millions of images scraped from the internet along with their text descriptions. Those captions come from things like the alt text that website owners upload with their images for accessibility and for search engines. So that's how engineers get these giant data sets, but then what do the models actually do with them? We might assume that when we give them a text prompt, like a banana inside a snow globe from 1960, they search through the training data to find related images and then copy over some of those pixels. But that's not what's happening. The new generated image doesn't come from the training data. It comes from the latent space of the deep learning model. That'll make sense in a minute. First, let's look at how the model learns. If I gave you these images and told you to match them to these captions, you'd have no problem. But what about now? This is what images look like to a machine, just pixel values for red, green, and blue. You just have to make a guess, and that's what the computer does too, at first. But then you could go through thousands of rounds of this and never figure out how to get better at it, whereas a computer can eventually figure out a method that works. That's what deep learning does. In order to understand that this arrangement of pixels is a banana and this arrangement of pixels is a balloon, it looks for metrics that help separate these images in mathematical space. So how about color? If we measure the amount of yellow in the image, that would put the banana over here and the balloon over here in this one-dimensional space. But then what if we run into this? Now our yellowness metric isn't very good at separating bananas from balloons. We need a different variable, so let's add an axis for roundness. Now we've got a two-dimensional space with the round balloons up here and the banana down here. But if we look at more data, we may come across a banana that's pretty round and a balloon that isn't. So maybe there's some way to measure shininess. Balloons usually have a shiny spot. Now we have a three-dimensional space. And ideally, when we get a new image, we can measure those three variables and see whether it falls in the banana region or the balloon region of the space. But what if we want our model to recognize not just bananas and balloons, but all these other things? Yellowness, roundness, and shininess don't capture what's distinct about these objects. We need better variables, and we need a lot more of them. That's what deep learning algorithms do as they go through all the training data. They find variables that help improve their performance on the task, and in the process, they build out a mathematical space with way more than 3 dimensions. We are incapable of picturing multidimensional space, but Midjourney's model offered this, and I like it. So we'll say this represents the latent space of the model, and it has more than 500 dimensions. Those 500 axes represent variables that humans wouldn't even recognize or have names for, but the result is that the space has meaningful clusters. A region that captures the essence of banananess, a region that represents the textures and colors of photos from the 1960s, an area for snow and an area for globes and snow globes somewhere in between. Any point in this space can be thought of as the recipe for a possible image, and the text prompt is what navigates us to that location. But then there's one more step. Translating a point in that mathematical space into an actual image in pixel space involves a generative process called diffusion. It starts with just noise and then, over a series of iterations, arranges pixels into a composition that makes sense to humans. Because of some randomness in the process, it will never return exactly the same image for the same prompt. And if you enter the prompt into a different model designed by different people and trained on different data, you'll get a different result, because you're in a different latent space.